Let's now talk about parabolas. Now, what are parabolas and how is it related to circle and how is it different from circle? Let's find out. Now, a parabola is a curve which is mirror symmetrical and is approximately U-shaped. And we all know that a parabola is the graph of a quadratic equation. Also, a parabola is a curve formed by the set of all points in a plane that are equidistant from a fixed line and a fixed point in the plane. Here's an illustration of a parabola where we can clearly see that all of the points on the parabola are equidistant from a fixed point and a fixed line. So that is a parabola. So here are the parts of a parabola. Let's start with the directrix. The directrix is a line used to help define a shape. Now, as you can see from our illustration, you can see that the directrix is outside our curve. And again, it helps define the shape of our curve. The next one is the focus. As you can see, the focus is a point inside our curve. A focus is a special point with reference to which any of a variety of curves is constructed. Now, the directrix is the fixed line and the focus is the fixed point that was mentioned in the definition of parabola. These are the fixed line and point which all the points on the parabola are equidistant from. The next part, we have the axis of symmetry. Now, this is the line perpendicular to the directrix and is passing through the focus. So, the axis of symmetry is the line that splits the parabola through the middle. From the word itself, axis of symmetry. The next one, we have the vertex. Now, the vertex is the point where the parabola intersects its axis of symmetry and is the point where the parabola is most sharply curved. We can see the vertex in our illustration. Now, the vertex is also either the maximum or minimum point of our parabola. The next one, we have the focal length, or is denoted by a or lowercase a. Now, the focal length is the distance between the focus and the vertex. Again, denoted by lowercase a. Now, if that is the focal length, again, any point on the parabola is equidistant from the focus and the directrix. Therefore, the vertex as well is equidistant from the focus and the directrix. So, if the focal length is the distance between the focus and the vertex and is denoted by a, therefore, the distance between the vertex and the directrix is also a. Then the next part, we have the latus rectum, or denoted by 4a. And as you can see, the latus rectum is the orange segment. The latus rectum is the segment which is parallel to the directrix, perpendicular to the axis of symmetry, and it also passes through the focus. Now, the latus rectum is 4a, therefore that is 4 times the focal length. And if it is 4a, or if the length of the latus rectum is 4a, each region of our latus rectum from the focus measures 2a. So those are the parts of a parabola. One of the most important properties of a parabola is it can either open upward, downward, to the right, or to the left. As you can see in our illustration here, we have a parabola that opens upward and to the right. Now, how can we determine in which direction our parabola will open depending on its equation? Now, here are the equations of a parabola. The first equation is if our parabola opens upward or downward. Our equation will be x minus h squared is equal to positive or negative 4a times y minus k. Now, if we can recall from our previous lesson, which is about circle, the coordinates of our center are denoted by hk. So this time, we have the vertex of our parabola. As you can see, h is always beside x and k is always beside y. Next, if our parabola opens to the right or to the left, our equation will be quantity y minus k squared is equal to positive or negative 4a times x minus h. Now, what did you notice about our equation? If our parabola opens upward or downward, our x will be squared. And if our parabola opens to the right or to the left, the squared one is the y variable. So that is how you can determine if your equation or if your parabola will open upward or downward or to the right or to the left. Now in these equations, h is the x-coordinate of the vertex and k is the y-coordinate of the vertex. Therefore, the vertex or the coordinates of the vertex are h, k. A is the focal length, again the distance between the focus and the vertex. And 4a again is the length of the latus rectum. Now, as you can see, we have positive or negative. If 4a is positive, our parabola will open upward or to the right. On the other hand, if 4a is negative, then our parabola will open downward or to the left. So those are the equations of parabola in standard form. Now let's have our first example. For example, we have to write the equation of a parabola in general form whose vertex is at 0, 0 and the focus is at 0, negative 2. Then we have to sketch the graph of our parabola. Now, to determine which equation we're going to use, let's first plot the point of our vertex, again at the origin or 0, 0. Now, the position of our focus will give us the information on what or which equation are we going to use. Now, the focus again is at 0, negative 2. So that is on the y-axis and we have 0, negative 2. Now, by just looking at the position of our vertex and the focus, we can assume that our parabola will face downward. So, we can use the equation quantity x minus h squared is equal to negative 4a times y minus k. Again, the squared one is x and our 4a is negative because our parabola will be facing downward. Now, since we already have our general or standard equation, we can now get our focal length, which is a is equal to 2. Now, where did that come from? As you can see, the distance between the vertex and the focus is 2 units. And again, the focal length is the distance between the vertex and the focus. Therefore, A is equal to 2. And by knowing the distance between the vertex and the focus, and again, if we're going to go back to our definition, the vertex is equidistant from the focus and the directrix. Therefore, the directrix will also be 2 units away from our vertex. So, let's count 2 units upward our vertex. Then there we have the directrix for our parabola. And as you can see, the equation of our directrix will be y is equal to 2. Now that we already have our vertex, focus, and directrix, we can now get our latus rectum. Again, from our definition, the latus rectum is 4 times the focal length. So if our focal length is 2, our latus rectum is 8. Now, what's the use of our latus rectum? Again, if the total length is 8, it means that each side of our focus must have 4 units. So let's plot the endpoints of our latus rectum. Again, as you can see, we have 4 units to the left of our focus and 4 units to the right of our focus. In total, we have 8 units of length of our latus rectum. So by just looking at our latus rectum or the endpoints of our latus rectum and the vertex, we can actually observe the behavior of our graph. So we can just connect all those points, then there we have the graph or the parabola for this given equation. But we still have to write the equation of our parabola in general form. Since the vertex is at the origin, we will just have x minus 0 squared. Therefore, that is just x squared is equal to, again, our 4a is 8. But since our parabola is facing downward, we must have a negative 4a. Therefore, we will have negative 8. Then we have y minus 0, that is y. So that is the equation in standard form. But we have to write our equation in general form. So we have to transpose negative 8y to the other side of the equation and equate our equation to 0. So the equation of this parabola in general form is x squared plus 8y is equal to 0. So that is how you write the equation of a parabola given the vertex and the focus. Next, for our second example, it's the other way around. Given the equation, we are going to find the parts of a parabola. Like for example, we have to find the coordinates of the vertex, focus, length of the latus rectum, and equation of the directrix and the axis of symmetry of the parabola with an equation of y squared minus 4y plus 8x minus 28 is equal to 0. Then again, we have to sketch the graph of our parabola. Now, as you can see, the given equation of the parabola is in general form. And just like in circles, we cannot really determine all the parts by just looking at our general form of equation. So we have to transform this into its standard form. And as you can see, the squared variable is y. Therefore, we are going to use quantity y minus k squared is equal to positive or negative 4a times x minus h. Now, how are we going to transform this into its standard form for us to determine all the parts? Just like in circles, we are going to apply completing the square. But our first step here, instead of just transposing all the constant term, we also have to transpose the term with the x variable because we have to isolate all the terms with the y variable on the other side of the equation. So let's transpose 8x minus 28. Therefore, we will have y squared minus 4y is equal to negative 8x plus 28. Then again, let's perform completing the square by dividing the coefficient of the first degree term by 2 and squaring it, then by writing it as the third term of the group. That applies to y squared minus 4y. Now half of negative 4 is negative 2, then square of it is 4. Therefore, we will have y squared minus 4y plus 4. Then again, don't forget to add 4 to the other side of the equation because that's how completing the square works. So we will have on the other side of the equation, we have negative 8x plus 28 plus 4. Then just combine the like terms and factor or get the factors of y squared minus 4y plus 4, which is y minus 2 squared, is equal to, again, combine like terms, we will have negative 8x plus 32. Again, we have to get the length of our latus rectum. Therefore, we have to factor out also the other side of the equation. So we will have y minus 2 squared is equal to, the common factors of negative 8 and 32 is negative 8. Therefore, we will have negative 8 times x minus 4. Now, our equation is in its standard form. We can now determine all the parts of our parabola. Again, our equation in standard form is quantity y minus 2 squared is equal to negative 8 times x minus 4. Now, by just looking at our standard form of equation, we can actually determine the coordinates of the vertex of our parabola. Now, let's recall that in circles, we can get the center by getting the values of h and k from the standard form of equation. Now, it is the same with parabolas. But always remember that h is always the one beside x and k is always the one beside y, which in this case, the expression with the x variable is x minus 4. Therefore, the x-coordinate or h is positive 4. And the y-coordinate or k, we have y minus 2. Therefore, k is positive 2. So the vertex is at positive 4, positive 2. Now, we can now plot the point for our vertex. Again, we have positive 4, positive 2. Now, since we already have our vertex, we can now determine our focal length by first determining our latus rectum, which obviously, again, we can see from our standard form of equation. Our latus rectum is again our 4a, therefore we have 8. Now, why is it positive when we have negative 8 from our standard form of equation? Always remember that the latus rectum is always an absolute value because it is a length. Therefore, our latus rectum is positive 8 regardless of the sign of our latus rectum or 4a. That is still positive 8 because the sign again just tells us where the direction of our parabola opens up. So the latus rectum is positive 8. So if our 4a is positive 8, what will be our focal length or a? Now just divide both sides by 4. Therefore, we will have 8 over 4, or the focal length is a is equal to 2. Therefore, if that is the focal length, we have to move 2 units from the vertex. Now where? In which direction? Is it to the left or to the right, since we have y squared? Now again, our 4a in our standard form is negative 8. So we move 2 units to the left to find our focus. So if our vertex is at 4, 2, then we move 2 units to the left to find our focus. Therefore, the coordinates of our focus are positive 2, positive 2. Now we can also move 2 units to the right of our vertex to find our directrix. Now we have the point for our directrix, and the equation of our directrix will be x is equal to 6. Then as you can see, unlike our first example, our axis of symmetry was the x-axis or the y-axis. This time, our axis of symmetry is y is equal to 2. Now we have already determined all the parts of our parabola. We can now sketch the graph by, again, plotting the points or the endpoints of our latus rectum. Again, since we have 8 as our latus rectum, we have, again, to count 4 units above our focus and 4 units below our focus to get a total length of 8. Then again, by just observing our endpoints of the latus rectum and the vertex, we can assume the behavior of our graph. So just connect the 3 points, and there we have the graph for y squared minus 4y plus 8x minus 28 is equal to 0.